In this video, we'll talk about XML files. First, we'll talk about what they are and what they look like. We'll briefly talk about XSD files, or rather XML schema document files, and then we'll show how to open up an XML file from our hard drive and read through the data in the file using the .NET Framework in C#. XML stands for Extensible Markup Language, and it's very similar to HTML in its use of tags. However, where HTML contains both unstructured information and how to format that information through the use of tags, XML contains structured information but contains no tags that indicate how the data should be formatted and displayed to the user. And the reason for this is that XML has a much different purpose than HTML does. XML is an easy way to store or transfer small sets of organized data between computers or between software. Now, the need for this might not be readily apparent, but consider that there are so many different software vendors that each have their own format to save their data in, and that's sometimes referred to as proprietary data formats. Transferring data between those software programs could be eased by a common language, or rather a common way of representing data that's easily readable by both humans and computers. Now, the format is not as efficient for storing or retrieving or searching through the data as the other more proprietary formats are, but it definitely has some benefits in so much that it's an open format, it's very portable. Now, the reason we're examining XML is because there's a lot of applications for it. When we were looking at the .xsd file in the previous lesson, I said that it defines the structure of an XML file. However, what might not have been very apparent was why it was used to also define a data set. Well, the reason is because the data set is managed internally by ADO.NET as an XML document. So in this manner, it makes it really easy to allow your user to retrieve data from the database in the application. Then the user can disconnect from the network or from the internet and still be able to make changes to the data to access the data. The XML then would just be saved from memory into a file on the user's hard drive and then retrieved if there's no network connection. And then later on, once they connect back to a network, all the changes that the user made can be saved back into the original data source, into the database. Or it could be imported into another program that also knows how to speak XML, and there's really a lot of creative ways that you can use this functionality within your applications. XML is also used for syndicated RSS feeds, which we're going to make use of in the last 5 videos of this lesson series. So I wanted you to become familiar with some of the basic concepts and how to navigate through the data in an XML document in C# and display it on the screen and manipulate it and so on. Let's take a look at a simple example of what an XML file looks like by creating a new application, which I've already taken the liberty of doing, called Lesson 10. And in this Lesson 10 project, what I want to do is select the Add New Item icon from the toolbar, and then select XML file, and I'm going to change the name of this from XML file 1 to cars.xml, and then select the Add button. So then it creates a new file called cars.xml in my project, and it opens up the file into the main area of my designer. So this creates for us a blank XML file. It does have one line of code at the very top, and this is the declaration of the XML file, and it defines the version of XML that's going to be used. Now, the specification for XML is constantly being reviewed and updated in minor ways that are really not important to know right now. But this little bit of information here is really for applications so that the application can know what version of the document should conform to. Now, the second part of this definition statement is the encoding style, which defines what set of characters to expect the document to be encoded in. Let's not worry too much about this for now. Instead, let's try creating something interesting. So what I'm going to do is just go to the next line here and start typing the word car lot. Notice I use an open bracket to start, and then I'm going to use a closed bracket, and when I do, the IDE automatically inserted a second tag of the same name, but it also has a /. Now, let me set up this example so you kind of understand what I'm going to try and do, or at least the philosophy of the example. I've created this fictitious scenario of a car lot, and I'm creating an XML document that contains the details of the cars that I have for sale on my car lot. Now, I want to exchange this list of cars with other car dealers in my area. Now, the thought is that I would give another car dealer a commission on any car that he sells from my car inventory. So if he doesn't have the car that his customer is looking for, he can search a database that's populated by the various car dealerships around town and see if anybody else has that car. Now, if I'm a dealer on the other side of town, the benefit to me is that I'm able to sell more cars to customers that I may not have had otherwise been able to reach. So this file could be loaded into whatever software each dealership uses for performing their own searches. Or perhaps this document could be crawled by some search engine out on the internet that displays cars over the web to people who are looking for car deals online. So whatever the case might be, I've got this concept of a car lot. And the first thing that I've created was an element called car lot. This is called the root element of the XML document. XML documents have to contain one element that encloses all the other elements within the body of the XML document. So this is called the root or the root element or the root node. And so sometimes I'm going to refer to the word node, and system.xml in the .NET Framework classes, they use the word node as well. It's just another word for element, and I'm going to use these interchangeably whenever I talk, just so you know. So I'm going to create a single car element within the car lot root. And the way I do that is go over here and do an open tag, type in the word car, and then a close tag. And notice that the IDE again completes the creation of the tag by creating an ending tag. So you have a begin and an end. And let me do another one as well. Here we go, car. So now I have two children elements within the parent element of car lot. Now the two car elements are considered to be sibling elements. And the car lot tag, which encloses those two sibling car elements, is considered to be their parent. So think in terms of familial relationships when you're working with hierarchies of XML data. Each element can contain other sub-elements, which in turn can contain other sub-elements, and so on. So how you structure the element hierarchy is really up to you and what your particular needs are. So elements can contain other elements, or elements can contain data. Let me illustrate this. So in this case, I've created another element called make, and it contains information, in this case, the make of the car, which I've defined between the two tags, the begin make tag and the end make tag, as Oldsmobile. So basically you see here again that the car element contains nodes, but the make element contains text. So an element can contain either other elements or can contain text or some value. It can contain one or the other, but it can't contain both. Or an element can contain neither, as in the case that I'm going to do right now, in the case of price. So you can see in this example that this isn't very useful because it doesn't contain elements, it doesn't contain a value, so what's the real purpose of this? Well, by itself there is no real purpose. But elements can also contain something called an attribute. So in this case, what I could do here is something like value equals 2500. Okay, so we've got an attribute called value, and the value of the property value, or the attribute value, is 2500. We could also put that here instead. So price equals 2500. Okay, and I can just delete this. So attributes are information that's encoded directly in the element definition. Now, when you use elements versus when you use attributes, that's completely up to you, which brings us to the next point. In XML, you define the structure of the document, and you define the tag names, or rather the element names, and you define the attribute names, anything you want. The tag names should be descriptive of the type of data that's going to be stored in the element, because this makes the XML document self-describing and easy to read by humans as well as computers. So for the most part, this is all pretty much free form. You can do whatever you want here. However, the structure that you choose should be consistent and follow some pattern. It wouldn't make a whole lot of sense to have one card defined like this. Where we got here, model, we're going to call this Cutlass Supreme, and year. Of course, I got to spell it correctly. And then have another card defined like this. Okay, now the two definitions for the car may convey the same thing to us as humans because we can kind of equate a company with the make, a style with the model, and the year that it was built with the year tag. But a computer isn't going to be able to make that distinction because it doesn't understand the context of what we're talking about. So there's nothing wrong with choosing either one of these ways to describe a car. You can pick either one, but you just need to pick one and stick with it. Now, the way you define the structure of an XML document and stick to it programmatically is through the use of an XSD file, or rather the XML schema document. This document defines the hierarchy and the structure and the data types that are used in your XML document. Then it's incumbent on your XML document to make sure that it follows this definition exactly. And if it doesn't follow the definition exactly, then your application will have unpredictable results. The application that depends on this XML file will probably fail because it's expecting certain words to be used or certain tag names to be used, the structure to be in a certain format, there to be, the child of the car lot should be the car, and the child of the car should be the make, model, year, and so on. If you don't follow this, then your application will probably fail. Now, we're not going to build an XML document for this example, and I'm not going to show how to associate an XML document with a corresponding XSD document because it's really beyond the scope of this lesson. The only reason I bring it up is because you saw an XSD document in the previous lesson, and now you kind of understand the relationship between the two. And then also so that you understand that while an XML document is free form and that you do have some flexibility there, really if you want to enforce a certain hierarchy of data so that it can be relied on to be programmed against or used in a programming scenario, then you're going to need to define an XSD document or be very disciplined to type things in exactly the way that they should appear each and every time. The XSD document then is just a way to enforce that, to make sure that you don't accidentally name something incorrectly or use improper styling choices in how you indent or embed the various elements. So what we're talking about here is the need for consistency, and this is called being valid. Valid documents follow the schema that they're associated with that defines the structure exactly. So if a document is considered valid, that means that the XML, the structure of the XML, the placement of the tags and everything follow the way that they were defined in an XML schema document. Now there's another test that makes sure that the XML document follows the rules of XML, and that is whether or not the document is considered to be well-formed. A well-formed XML document has the tags in the right spots, it's not missing any ending tags, they're not transposed so that you have this tag outside of here. You can see that when I do that, I get these red squiggly lines. That's because the document is no longer considered to be well formed. The embedding is all messed up. Now when I move this back, we're able to get it back into a correct state, a well-formed state. So the difference between being well-formed and being valid is very subtle. A valid document must be well-formed, But a well-formed document doesn't necessarily have to be valid. This document is well-formed, but it's not necessarily valid because I've used two different ways of defining what a car looks like. So I'm going to correct that right now by just deleting this from our document. In fact, what I'm going to do is just paste in a new set of XML here that I created earlier for my car lot. So I've got the concept of a make, model, and elapsed miles for both an Oldsmobile Cutlass Supreme and a Chevy Camaro. So I currently have two cars on my car lot. So this is what my XML file is going to look like. If you want to follow along, please pause the video here and create an XML document, just like I did a moment ago, that looks exactly like this. Okay, the next thing I want to do with this example is show you how to access this XML document that we created through the use of C# and the system.xml class namespace in the .NET Framework. So what I'm going to do here is add a button onto my form, and I'm just going to create a real cheesy example here just so we can fully exercise how this thing works. I'm going to add a bunch of label controls, just label 1 through 7. We'll use each of these in just a moment. In fact, I'm going to pin this down. Now this isn't going to be a terribly practical example, but it will show you how to open up an XML document off of the hard drive and then how to display and navigate through the XML document using the system.xml namespaces. So let's close that down for now. Let's hit save. Now, the way that you open up an XML document and begin to work with it may not be so straightforward. You actually have to take it in 3 different steps. The first step is to open up the file and read it from the hard drive into the computer's memory. And you do this through the use of the system.io.streamReader class. Once the file is read into memory, then it has to be converted into XML. And so we'll use a different class called the XML text reader from our system.xml namespace. Now finally, after it's been parsed by the XML text reader, and parse just means to look through it and make sure that it's well formed, that it's actually an XML document, and it does some other little reading and optimization from it. Then we're going to need to read it into a format that it can be worked with, and so we'll use an XML document object in order to do that. So let's just double click our button, and I'm going to paste in some code. So first of all, we're using that StreamReader class that we talked about, system.io.streamReader, and we're going to call it sr equals new system.io.streamReader, and we're going to pass in a constructor. We're going to pass in the location of the cars.xml file. Now, the use of the little @ symbol here just means that we're going to look in our current the current directory for the project. If we didn't use this, then it would look elsewhere on the hard drive for that file, and so it probably wouldn't find it, and we'd get an exception right here. Now clearly, if we're wanting to create a more stable application, we would want to make this more flexible and not hard code the file name. But for our purposes and just getting started, this will work just fine. So the next step then is to take that data that's in memory on the computer and turn it into XML. And the way we do that is through the use of the system.xml.xml text reader. So we create a new instance of that, and we pass in as an argument in the constructor the StreamReader object that we just created in the previous line of code. So now that we've determined that this is indeed XML and it's been parsed correctly, we need to put it in a format that we can work with it, to look through it, to navigate through it, and so on. And the way we do that is to put it into an XML document. So you can see here we created a new XML document, carlotdoc equal new system.xml XML document. So now we have our carlotdoc object that we can use to parse through and work with. And we need one other step here, and that is to just creating it isn't enough. We have to pass in a reference to the text reader, the XML text reader. So we'll do carlot.doc, carlotdoc.load, and we'll pass in the XML text reader. And now it's loaded into our carlotdoc object. One of the first things that we can do now that we have the XML parsed out for us is to use the inner text property in order to display the entire contents of our document. So let's do this. Carlot dot inner text. Okay, so let's set that equal to label1.text equals inner text. Let's save this and then run our application and make sure that it works up to this point. And when we do, notice that we get a file not found exception. Basically, whenever our application is running in debug mode, a copy of the cars.xml file needs to be in the bin directory / debug directory. So let's do that right now. Let's copy our cars file. And we'll go to our Windows Explorer, Visual Studio 2005, Projects, Lesson 10, and we'll just continue going down until we find the file. Looks like we lost it somewhere here, so I'm going to go back to the Lesson 10 directory, copy it, and then paste it in the debug directory. Okay. So let's go ahead and run the application again. Okay, so now we can see that we have Oldsmobile Cutlass Supreme 5000 Chevrolet Camaro 60,000. Okay, the data is not very well formatted. It's just all run together. Notice that we don't have any tags listed whenever we're using the inner text property. And quite honestly, this isn't very useful in its current format. So what we'll need to do is navigate to one of the child nodes of our root element and start grabbing information out from it. So let's do this. I'm going to paste in some comments so we can remember what we want here. And we're going to set the value of label2.text equal to carlot.firstchild.innerText. And to make it more obvious what this is, let's do this. So here we're going to grab the first child node and display its inner text. Again, the inner text would just be what's contained within that first child node. So let's run this. Select our button. Okay, so the first child node is actually our XML definition, version 1.0 encoding UTF-8. Not exactly what we were looking for. So let's continue moving on. Let's use some navigation in order to get from the first child to the next child. And there's a bunch of different ways we could go about this. And this might not be the most efficient, but what I want to do is just show you how you can navigate through your document. So we have our second child node. So we'll do this, carlot.firstchild.nextSibling. So the next sibling in line should be the carlot root node, hopefully. So let's do this, inner text. Okay. And let's save it, and let's run it. Okay, so our second child node would contain then the inner text. Notice that the second child node's inner text is the exact same as the inner text for the entire document. So that inner text on the document object will help us get directly to the information that we're looking for. It'll help us avoid any of the definition type information at the top of the document, but we still get access to it by using the first child method of our document object. Okay, so let's move on. Next thing I'm going to do is just get a reference to the carlot object. So let's do this, system.xml.xml node carlot equals carlot dot first child dot next sibling. Okay, so now I'm working just with the car lot, and I can do something like this. Um, let's populate label 4 equals, now that we have a reference to car lot, we'll just grab the inner text of car lot. Then we'll go label 5.text equals the first child of car lot. So what do you think I'll do for that? Car lot, whoops, car lot dot first child dot inner text, okay? And then let's just get kind of funny here. Label 6.text equals the first child of the first child of car lot. So what do you suppose that would be? Car lot dot first child dot inner text. Okay, so let's run this now and look at the 4th, 5th, and 6th labels. Okay, so now that we have a reference to car lot, we did the inner text, which would be just exactly like what we saw in the previous example, in the first example. And now we're grabbing the first child of car lot, which would be that Oldsmobile Cutlass Supreme that we created. And now what we want to do is just grab the first sub-element or the first child of that Oldsmobile Cutlass Supreme, which allows us to grab the word Oldsmobile. Okay? Now, quite honestly, this isn't a very efficient way to go through an XML document, but I just wanted to show you the ability for you to navigate from the first child to the next sibling and so on in order to go through each node and find what you're looking for with an XML document. So this is using more of a parent-child sibling metaphor. It's one good way to navigate through the XML document, but it can be tedious sometimes and problematic because the document may not be formed exactly the way that your program might anticipate it. It still might be well formed, it still might be valid, but just different than what your application is expecting. So another way to utilize an XML document is through the use of an XPath expression. Now XPath is a companion technology to XML that allows you to search through the XML document to find exactly what you're looking for. So I'm just going to paste in an example here and not type the whole thing out. But let's talk about this. First of all, I'm going to grab a node list, an XML node list that I'm calling car lot items, and I'm going to use my car lot doc that I created earlier and use the select nodes method in order to find all the nodes of type car lot slash car. So what do you suppose this will return back to me? It'll return two nodes, one for Oldsmobile, one for the Chevy, that allow me then to work with just those two nodes. So I didn't have to go, first sibling, next sibling, so on. I'm able to just search directly and bring back all of the nodes that match this criteria that I've created. You can see in the previous example that I commented out that I'm able to find all of the nodes that match car lot. Now that would only return back one node for the car lot node. It wouldn't make a whole lot of sense to use that. Okay, but this allows me to go one level deeper, and I could even search one level deeper and return all the nodes that, for example, match that sequence, car lot, car, make. We're not going to do that for right now. The next line of code is to actually grab one node, which I'm calling the make, and what I'm doing now is working with that list of items that were returned in the previous line of code. So I had two items, the Oldsmobile and the Chevy. I'm going to work with the first item, item sub-0, and I'm going to select a single node that is a child of either the first or second car. I'm going to grab that node that defines the make of the car. So what would you expect this line of code to return? Let's run it and find out. you can see here that it returned the word Oldsmobile. Now, why did it do that? Because again, we first of all grabbed all of the nodes that matched car lot car, which would bring back this and this. Then we worked with the 0th or the first item within that list, which would be this one, and we said find the element within car called make and return the value, which was Oldsmobile. So I hope that you can see two things from this lesson. First of all, that there's nothing really magical about XML files. It's just text. You can create any format you want for it, use any keywords that you want to use. You just need to make sure that you go about it in a consistent way whenever you're defining the data that's within your XML file. And then the second thing is that it's very easy to navigate through the XML document in .NET. You can either go about it from what I call the parent-child sibling metaphor, where you're able to find the parent or the child or the next child or the next child and its children and so on. Think of it in those terms. Or to use an XPath expression where you're searching for elements within your XML document that match a certain pattern based on the names of the tags that you used. Now, if this doesn't make complete and total sense to you, watch the video again. Don't make too much out of it. It's a very easy concept, and although there are more things that we can add to your knowledge, this will get us as far as we need to go for the lesson that we're going to create, or the example that we're going to create in the next 5 lessons at the very end of this series of lessons. Over time, you can add more to your knowledge, so don't be intimidated by this. It's a very easy concept. So if you enjoyed this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one, aimed at all skill levels on many different topics related to C#, Visual Basic.net, ASP.NET, and more. Thank you.